In the sponsor there will be a agreement. Okay, so that's the, we can call it as a TSDT, a transfer study data transfer agreement, or some people will call it DTG, data transfer agreement. Okay, whatever they may be. So in that agreement, what is going to mention that, so how they are going to analyze the data, and how though they are going to send it the data, means like is it Excel format or the SAS format, or any flat files. Okay, and also how, I mean, what kind of test they are test it is they are going to analyze. So how the results is going to provide the which units, and then what is the data frequency? How many times they can send it to monthly or monthly twice or weekly or whatever the frequency of the data transfer. So the each and everything they'll mention in that agreement. Okay. So as a programmer, we should aware of that agreement as well, TSDTA. Okay, so now the local lab means, okay, whatever the test SCDs and the test results will be going to perform in the hospital itself. There is a local lab, we can say. So the central lab means the third party vendor. When they will get the third party vendor, we need to make sure that the data is coming from third party. So it's a bit challenge. Why? Because we need to club these data to the CRF data. So when we are merging the vendor data to the CRF data, we need to make sure that, okay, by subject accession number we need to merge. Why? Because it should not be the direct you can merge. Why? Because if the one subject results might be merged to the another subject, this is a very huge issue. So that's why we need to make sure that match measure. So how we are going to get that match measure? Per subject, per visit, accession number. Accession number is the important. Accession number is nothing but it's a sample ID. Nothing but, okay, if you go, I mean, if you can very commonly see in the diagnostic center, previous older days they'll write something on the sample. But nowadays, if you go any diagnostic center, they will print the barcode sheet and stick on the vial. Okay, that sample vial, they'll stick the one barcode. Okay, that is system generated barcode. So that barcode is nothing but the one accession number, that unique number. Okay, so to avoid the ambiguous situations and then to avoid the misplace of the samples and all this thing, so that accession number is important. While we merging the data to CRF to vendor to CRF, we will use that particular accession numbers. Okay, so that is the concept of the LB. So that's why we'll say that LB is a bit challenging domain. Anyway, so when it comes to the regular structure and all these things, it looks like similar to the other finding domains only. So here the one record per lab test, per time point, per visit. Obviously, so the finding domains data will be captured based on the visits and then sometimes time points as well. Okay, within that visit, it might capture multiple times based on the time points. Okay, so if you can see the variable names, these four common you already know, like study ID, domain, user subject ID, LB sequence, and then group ID, ref ID, sponsor ID also know, like these variables we already commonly seen in the other domains. Okay, so the LB test CD, LB test CD is the topic variable of your lab domain. Okay, so that SCD is the topic variable for the all finding domains, that already you know. Okay, so and then here the LB test is the particular full name of the particular test. Okay, so the LB cat and SCAT. So this is the category and subcategory of your particular test. For example, hematology, urine analysis, chemistry. These are the categories. Okay, and then some other subcategories like this. Okay, differential coagulation, liver function, electrolysis. So these are the subcategories. Some of the examples. So LBORRES, okay, the original results from the particular CRF of this database. Okay, this is the original results. Okay, so the particular test results, and then LBORRESU. So the, okay, so this is the original results unit. I mean, the original results is captured on the which visits. Okay, then the LBORRESU LB. Okay, so the original results units. Okay, so second. Next, this, sorry, I confused. Okay, so this LB or ESU is the original results units. Okay, the next is that LB OR NR LO LB OR NR HI. Okay, these two are the new variable when it comes to the LB. So if you have seen in the like test SCD results and the units and the standard results, character standard result numeric, these variables you already seen in the vital signs, another finding domain. But when it comes to the LB, along with those variables, you can see these two extra variables, LB OR NR LO, LB OR NR LI. Okay, so this is nothing but the normal range indicator, slow normal range indicator high. Okay, for example, if you can see the reference range lower limit in original units, reference range upper limit in original unit, this is nothing but okay. So if you go and see any like diagnostic reports, okay, like RBC, WBC count, hematology, like blood picture, urine analysis, whatever this test related anything, if you have any reports at your home, you go and check that. So how they will provide, okay, first the test name, and then what is the value of the particular test for this subject, and then adjacent to that they will give the biological reference range. For example, so let's assume that let's assume that WBC count, okay. So for the subject, okay, WBC count is the 1.9 million, or okay, whatever the range they will give, 1.9 is the result, and then adjacent to that they will give that 1.5 to 3.5 million is the normal range. Okay, this number I'm just giving for an example, I'm not exactly saying that the biological reference is what is that RBC. So it means, okay, the subject will have that particular result in between that particular, then we can consider as a normal result. If it's a low or if it's high, we can say that abnormal, right? So that 1.5 is the lower range, 3.5 million is the higher range. So that biological reference range, these two variables, that particular test and the particular original result, what is the reference range? That is the lower limit and upper limit of the particular biological reference range indicators. Is that clear for everyone?
Yes, sir, clear.
Okay, great. So then LB, ST or ESC, this is nothing but the standard results character format. Here in the LB very commonly we can see that, okay, so original results to standard results we might have to convert that by using the conversion factor. What is conversion factor? We have already seen in the while discussing on the vital signs. Okay, so some of the tests and test series results will capture in the different results in the original, but we have to convert into the SI, I mean, okay, standard units. Okay, so that's why the what conversion factor we can use and the convert. Okay, so sometimes the original results, the character results are both same way because it is captured in the standard units only. Then LBSTRESN is nothing but the standard results in numeric format. So that particular LBSTRESU is the like standard units. Next, LBSTRNRLO, LBSTRNRHI. So these are the original results, low and high normal range indicators. Means, for example, this test CD originally what is captured the which units, within that units this is the low and high. But when it comes to the high and low of the standard results might be different. Why? Because, for example, okay, let's assume any test is the, okay, this is captured in the gram per liter, but that standard units is the mg per liter, let's assume. Then obviously we need to divide it by conversion factor is 1000 for that. So this is the gram per liter is the original results, and then mg per liter is the standard results. So then this biological reference ranges also will be changed, right, based on the units. So that is the standard high and low range indicators. Okay, so LBSTR NRLO, LBSTR NRHA. Okay, the next LBSTR NRC, reference range for the characters. Okay, again this is the same for the character results. Okay, so this is another important variable, LBNRINT. Okay, this is the reference range indicator. So this is derived variable. This will not supposed to capture in the CRF or somewhere. These are the capture in the data, but this will, we need to derive that. How we are going to derive that? Okay, this is simple. Okay, so we already know the result, we already know the normal range indicators, high and low value. So this result is falling in between these biological reference range, we can consider it as a normal. For example, this is falling out of the range, we can say that it's abnormal or high or low values. Okay. So for example, RBC count, we say that okay, it's a 1.5 to 3.5 million is a normal. If it's a 1.3 million, then it's a low. If it's a 4.3 million, it's a high. Okay, this we can consider it as abnormal or low or high. These kind of values will come. So what we will do, so this original results is going to compare with the high and low reference range indicator. If this is falling in between that indicators, then we can consider as a normal, or else if it's falling out of the range, it's abnormal, and it might be low or it might be the high. Okay, that's what LBNR. Okay, so next is the LB start. LB start, and the reason is nothing but you already know, if there are any test is not captured. Okay, so status of the particular test. Okay, it is not done. When it's not done, then what is the reason for it's not captured? The reason will have to provide it. Next, LB NAM. Okay, so LB NAM is nothing but okay. So who performed this test? Okay, investigator or the vendor name, whatever the may be. So we can map it here. So LB LONIC. Okay, this is the LONIC code. Okay, so we'll have a LONIC dictionary that is nothing but okay, each and every test will have a one particular code. So that code comes from the LONIC code. Okay, so the LB spec is nothing but the specimen type. If you remember, whenever we give the sample, there will be specimen type like a serum or plasma or urine, whatever that is the specimen. Okay, LB spec. Then the specimen condition. Okay, what is the condition of the specimen? Okay, that might be the hemolyzed, isopathetic. Okay, so lipemic. These are the condition of the particular sample specimen. And then LB method. What is the method of that particular test is done? Sometimes, for example, if the pH. Okay, pH is sometimes we can titrate with the measure, and then we can check with the dipstick. Okay, if we use the pH litmus paper into the particular sample, it will turns to the different colors. Based on the colors, we can say that pH is this spot. This is the pH value. So, but the same pH we can consider with the, we can calculate with the measure also. Okay, so it depends what is the method of that particular test is performed. Okay, these are the some of the examples like electrophoresis and then dipstick, and then AIA, so enzyme immunoassay. And then LBBLFL, already we discussed, okay, in the finding domains baseline calculation, we need to do that. Baseline flag is nothing but the latest non-missing value prior to the treatment, okay. So we have to make sure that that value should be latest, and then value should be prior to the treatment, and then the value should be non-missing value. LB fast is nothing but it's a fast in condition. When the sample is collected for these, okay, is it a fast in condition or fed condition? If it's a fast in condition, they should have put that yes. So if there are any variable derived, that derived flag should be y. Okay, so these, for example, LB, these variables are the conversion factors, and then if it's happened derived, then that particular record we can put that derived flag should be y. And then LB tox and then toxic grade. Okay, there will be a toxic grade, CTC AE grades. We can say that each and every test results based on that. Okay, so we can say that some, I mean, this will not capture in each and every study, some oncology related stuff, then we can consider it. So this is grades will comes from the NCI, National Cancer Institute. Okay, so CTC AE grades we can say like it's a grade 1, grade 2, grade 3 results. So that we can consider as a toxic grades. Okay, LB tox and toxic grade. So the next is that the visit num, visit device. This we already know for the other finding domains. So the visit num is nothing but the particular visit numeric number, and the visit is the name of that particular visit. Visit device is the what was the planned day for that particular visit. The LBDTC is nothing but the data of collection of the sample. So LBENDTC, the basically generally this will not capture. Okay, this is a permissible variable, but because the sample collection, what was the time it will take, what is the start date, and that is the and time, that would be the end date. But if there are any particular time consuming test, then that might be by the end of that particular sample. So the LBDY is nothing but this LBDTC. This LBDY is the study day of the particular sample collected. And then LBTPT, so this why you already know the time point variables. TPT is the time point, is nothing but okay, pre-dose, post-dose, okay, like 5 minutes post. These are the TPTs. And the TPT num is nothing but individual TPT will have the one numeric number like visit num. This is the TPT num. So LBLTM, elapsed time point, is nothing but based on this time point. So we can put that okay, it's a PT 8H, PT minus PT 15 means. So this is the 15 m is the 15 minutes, minus PT is the period of time of prior to treatment. Okay, so prior to treatment at the post treatment. So the PT is the post treatment, okay? So period of time, actually name. The definition is that, okay? But this is the PT is the after treatment, minus PT is the before treatment. So the 15 minutes, 8H, okay, 1 day, 1 week, whatever the time, we can put that in the elapsed time point level. So LB RFT DTC, LB TPTRF, these are the two variables. This will give the one of the particular milestone. Like if you can see, this is the previous dose, previous meal, this is the milestone. The particular previous dose when it has happened, particular previous meal when it was happened, that is the RFTD, the date will comes to the here. Okay, so if you can see this, most of the variables are very common from the like other finding domain what we have seen in the vital signs. The only 1, 2, 3 things we have seen that, okay, specimen condition, specimen method, and the specimen, okay, LB spec, specimen condition, specimen method, and then next this is the original results, high low values, biological reference range indicator, character results, standard results, original range, high low indicators, and then this is the LB and RNA. These are the 5 to 6 variables is new to this LB domain. Okay, but if you can see, go in any finding domains, this vital signs and LB what I have seen, the same variable naming convention, same role of that particular variable will be there. The test SCD names will be changed. Okay, the same picture here, and then each and every domain and end of the domain we should check that the assumption of the particular domain. So if you can see that there are a lot of assumption for the LBU and then real time, if you can see this, okay. So these are the assumption. You go and read this, okay. With this table, they will explain the each and row by row wise. So if you can see, this is the LB thing. So this is the subject and then sequence number, test, okay. So albumin, so LB is albumin, okay, and then this is a test CD and then test name. So LB is alkaline phosphate, okay. Category is that chemistry. Okay, if you can see this leukocytes, lymphocytes is the hematology, okay. The pH is the urine analysis, okay, and then LBS cap is that, okay, differential, and then the LBRS, if you can see the numbers, it will come. So the results, units, results and the units, and then reference range indicator. If you can see this, the albumin is that gram per liter is the original captured units. So the result is the 30, but actually the normal range is the 35 to 50 is the normal range, okay. So they have converted into 3, and then what is that particular standard results? If you can see here, you can find the standard results is this gram per dl, but actually it is captured in the gram per liter, okay. So now this is the 3.5 to 5 is the standard results reference range indicator, low and high values. So if you can see this LB and RND, the value is low. Why? Because this is the value, 30 is the particular results, but it is a 35 to 40. So this range is below 35. So that's why this is the, yeah, tell me.
It's a low, sir. Sir, if it is when we call it as abnormal, sir, is there any indication?
That's what, it's low or high, it's abnormal, right? Okay. So for example, if you can see this, okay. So this is, okay, this is the last test, okay. So the pH test, pH or what? Urine analysis, protein, okay. So the PROT, okay, the protein is in the urine analysis, okay. So the LB or this is captured is a moderate, okay. So the LB STR NRC is that, okay, standard is negative to trace. So LBNR is negative to traces, there is no traces. This is abnormal. Actually, it traces the some values. Okay.
Yes.
That is abnormal. But here is the, this is the ranges, right? We can say that high and low. But some of the tests will be positive, negative to trace this, we can get abnormal.
Okay, fine, sir. If it is severe, then it will call it as a abnormal.
Yeah, severe means it's not a regular expected results. Yeah, that's it. Okay. Yeah, so if you can see, these are test SCDs, related results, and then baseline flag, and then buried flag, and then visit num, visit, and LBDTC. So for some of the other examples also given, please go and read that, and keep on saying that each and every domain once we completed, you should remember that variable naming convention, what kind of data is going to come to the particular variable, and then what is the assumption of that variable. That is very, very, very important. Without this knowledge, the next we are going to start the college classes, real-time classes, that is not easy to understand. Okay, so the LB is a bit tough to understand and read the assumptions. So what I will do, I will stop it today here.